what should the reservoir level H to maintain a flow of Q equals to the 100 m cube on second through the commercial steel annulus 30 meter long as shown here. L neglect entrance effect and take neglect effect and row specification of water at that condition. So to calculating the fully developed annulus flow, minor losses neglected, we should find first Reynolds number and friction factor and also head loss for this pipe here, and then we can calculate the H, the reservoir level, with the given data of the fluid here, flow and fluid. Here we can calculate V equals to Q on A. A is the cross section of the annulus cross section pipe. So we can write on the cross section, which is so V equals to, with calculating V, we can calculate DH. DH in the annulus annulus cross section, which was A minus B. In this case, we have 2 from the picture minus the inner diameter that equals to the hydraulic diameter. With hydraulic diameter, we can calculate Reynolds. VD on nu, we have V DH on nu so Reynolds equals to turbulent so to calculating the head of the reservoir, we should write the energy equation between 2 points. The equation for energy balance between 2 points, point 1 at the reservoir level and point 2 at the exit of the pipe, we can write P1 on row G plus alpha 1 V1 on 2 P2 on row G V2 on 2G So if we consider the zero cation is here, we can write this relation P1 for pressure gauge and P2 are equal. We can eliminate these two parts. For part 1 also we have big tank here and V1 is equals to 0 because Z1 equals to H1. So we have 0 plus 0. No. Let me write H alpha 2 V2 2G plus Z2 plus loose. So now we can calculate H. This also is 0 alpha 2 V2 square. We have a relation for the head loose for the pipe, which is F L on DH V2 square on 2G. With the simplification, we can write HF is we can assume that alpha 2 approximately is to 1.03 and there is also F here. Epsilon on DH is approximately, for epsilon from the table we can table 6.1. On DH, hydraulic diameter, which was calculated before, we can obtain epsilon on DH equals to and Reynolds DH also can be calculated before. We can use the Lebrock function to calculate the friction factor, logarithm of F equals to, with replacing to the formulation above, we can calculate H equals to the to have a flow rate of m cube on second.